Stats class, on this example, we are looking at the idea of a p-value and what does that have to do with hypothesis testing, and in particular, what is the p-value method of conducting a hypothesis test. The first thing you see here is we're testing the claim that p is greater than 0.9, which makes this a right-tailed test. So I'm going to put right-tailed test on there. So there's just the visual of the test. And then the test statistic is 0.91. That's not p hat, that's the test statistic. So this would be like a z-score. So it's like how many standard deviations are we above the mean, okay? But the p-value, what I want you to see here is if I scroll down here, I have p-value right tail. So if I'm doing a right tail test, this is the one I'm going to pick. I'm going to click that. And the p-value is just the area beyond your sample proportion. And when you standardize your test, so when you get a test statistic, it's the area beyond this in the distribution that you are working on. So in this particular example, it would be the z distribution, the standard normal distribution, and it's the area beyond the 0.91. So I can select the standard normal distribution, normal dist, just leave the parentheses blank. I'm going to zoom in on it, and then cumulative probability, because this is a right-tailed test, and let me go ahead and select that. This is a right-tailed test because the alternate hypothesis is p is greater than 0.9. So because of that, I'm going to select right on this, okay? And I'm going to select that the z-score, and it's calling it x, but that's fine. It's just a general number, is greater than the value that we're given, the 0.91. So I'm just going to put a 0.91 in there, and that is my p-value, okay? So I'm going to click OK. What's the p-value? It wants me to round this to 3 places. It will display 3 places right here, 0.181. It'll give you way more than that if you click this and press that button right there. So there is the p-value to 3 places, 0.181. And then it wants to know, well, what do we do? Do we reject or do we fail to reject? So there's their 2 possibilities. When you get a p-value, you're going to reject or fail to reject. And then there's 2 reasons that go with it. If you reject, it's because there's sufficient evidence. If you fail to reject, it's because there's not sufficient evidence. And if you look, this is just every combination of those 2 things. It's reject, fail to reject. There is not sufficient evidence. There is sufficient evidence. When you reject, it's because you do have sufficient evidence. When you fail to reject, it's because you don't. And the evidence is based on the p-value. If your p-value is less than the significance level, 0.01, then you're going to reject. If the p-value is not less than the significance level, which we don't have it here, then you're going to fail to reject. All right? And again, if you're failing to reject, it's because there's not sufficient evidence. So that's the combination that we're after here.